Hi everybody, welcome to my YouTube channel Guidancee Education channel. In this video we are continuing chapter 1 Charges and Electric Field, class 12 Physics. The topics discussed are electric flux linked with a cube, electric flux linked with a sphere. These two topics are electric flux linked with closed surfaces. These two topics come under the main topic electric flux through a closed surface. So I would recommend you to watch the video completely without skipping so that you get the concepts clear. If this video helped you, like the video, share the video with your friends who may also be benefited, and also subscribe my channel and press the bell button so that you get intimated as soon as videos are posted. Please leave your comments in the comment box below. Do not forget to go through the description box where you can get the details of the video. Thank you. Now we will discuss electric flux through closed surface. That is, electric flux linked with a surface. What is a closed surface? A closed surface is one which is closed from all around. It may be of different shapes. Here we will consider a cube and a sphere. First we will consider electric flux linked with a cube which is resting in uniform electric field. A cube has 6 faces. Let us mark them. A, B, C, the inner face, D, the outer face facing us, E, the top face, and F, the bottom face. The red lines represent uniform electric field. The coordinate of the direction of the electric field is only along the x-axis. Electric flux is equal to E ds cos theta. You may click the I button in order to watch the derivation of this formula. Theta is the angle between direction of electric field and area vector. Now let us know more about the direction of area vector for a closed surface. But before that, let us recall how we considered the direction of area vector in the case of an open plane surface. These are the electric field lines which pass through the surface. The area vector can be drawn either outward or inward. For open plane surface, we considered the inward direction. By convention, in the case of a closed surface, the outward direction is taken. For open surface, area vector is taken towards the inside. For a closed surface, the direction of the area vector, that is the direction of the perpendicular drawn to the surface, is taken as the one towards the outside. So, for face A, this is the direction of the area vector. This is the area vector for face B. Flux for face A will be given by EdA cos theta. Theta is equal to 180 degrees because the area vector and electric field line are anti-parallel. They are at 180 degrees. Therefore, this becomes equal to negative EdA because cos 180 is equal to negative 1. Now let us see for face B. Electric flux for B is equal to EdB cos theta. Here theta is equal to 0 because the direction of electric field and that of area vector are parallel to each other. So EdB cos 0. Cos 0 is equal to 1. So the value is EdB. It is a positive value. The magnitude of area of A and B are same. Electric field also is same. So the magnitude of EdA and EdB are same. But one is negative and the other is positive. So they get cancelled. What about the flux for the other four faces of the cube? Here the electric field direction is only along the x component. There is no component along the y direction or the z direction. So the other phases do not get linked with the flux. So only phase A and phase B get linked with the flux, and we have already seen that. The total electric flux for a closed line, that is for a closed surface, is given by the closed integral. That is the total of the electric flux for each and every single plane surface constituting the closed surface. So the total electric flux for a closed surface in an electric field is equal to closed integral of E dot ds. This S stands for all the various phases of the cube, and here the total flux is equal to 0 because negative EdA and positive EdB get cancelled. I hope it is quite clear. Now we will see electric flux linked with a sphere. Consider a sphere in an external uniform electric field. Each area element on one side of the sphere will have a corresponding area element just on the opposite side. So the electric flux on one area element of the sphere will be cancelled by the electric flux on the area element diametrically opposite to that. This is because, as you know, the area vector of these 2 points will be diametrically opposite. If you represent a sphere in 2 dimensions, it will be like a circle. For a small plane area on this side, there will be another plane area just on the opposite side. For any such small area on one side, there will be a similar small area just on the opposite side. Though we have used a 2D picture for the purpose of explanation, you have to imagine this in the 3D format. The direction of the area vector of these elements will be diametrically opposite. Remember, for closed surfaces, outward direction of the area vector is considered. That is the convention. So the total electric flux, that is the closed integral of the electric flux of the various elements in the sphere, will be equal to 0. That is E ds will be 0. So the total electric flux for a cube or a sphere kept in an external electric field will be equal to 0. Remember this point. Okay, I hope it is clear. Let us attempt this problem. Problems are very important in physics. When we learn one concept, that we should also practice some problems related with that topic. That will help to score good marks in physics. This problem contains 3 sections. We will take one by one. Section A, 2 metal spheres of unequal charge Q1 and Q2 are kept separated by a distance r. What will be the Coulomb's force between them? We know the formula for calculating Coulomb's force between charges. Let us make a diagram of the details given in the problem. This is charge Q1, this is charge Q2. They are unequal, so I have shown different sizes. We will mark the center of each charge. The distance between their centers is what is called the distance r. It is very easy. We can easily substitute these quantities in the formula. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. What is the unit? Newton per coulomb. So many Newton per coulomb. We can imagine Q1 is stronger and Q2 is weaker. So Q1 pushes Q2 away. So we have done section A. Now section B. The strong person and weak person are brought close together. Then what will happen? When they were at a distance, the strong person, that is Q1, pushed Q2, the weaker person, away. But when they are close together, Q1 behaves differently. They pool their strength together. That is Q1 plus Q2, and let us consider it as Q. Then they share the charge equally among them. In physics we say when two unequal charges are brought close together, their charges become equal. The charge distribution changes. Now Q1 is equal to Q by 2 and Q2 also is equal to Q by 2. I will note it down. As the charge distribution changes, the center of the charge also gets slightly shifted away. The distance is taken from the center of one charge to the other. So, the magnitude of the distance between the two increases. As Q1 and Q2 has the same strength now, they push each other with same strength. But the force between them becomes less because the distance increases. So, will the forces be same? No. The answer is no. Now, what are the reason? The reason is given as a list there. I have given 3 points there. Now, let us take up C. After keeping the stronger and weaker person together for some time, they are again separated by a distance r. What will be the force between them? As the charge distribution has changed, the force will be less. But they will push each other, that is repel each other with the same force because they have the same charge now. I hope it is quite clear. Now the second question, you might have seen this question in many books. If you missed, go through this. Is the given diagram correct? If not, point out the corrections needed. When we analyze the figure, we find a positive irregular object and a negative irregular object. Their electric fields are shown. We have to point out the corrections needed. When the positively charged object is taken separately, the direction of the field line appears to be correct. They are directed outward. So also the negatively charged object, the field lines are directed inward. But a closer look on the diagram reveals that one field line is shown as closed loop. That is incorrect. Electric field lines do not form loops. The first part of the question asks you whether the diagram is correct. So the answer is no. I will note the first point to be corrected. Electric field lines should not be shown as closed loops. Let us see the second point. Here you find one field line crossing another field line. Anyway, this is wrong. This loop formation is wrong. In spite of that, here it is crossing. So let us note it down. Electric field lines do not cross each other. Another striking defect is the field lines are shown inclined to the surface. Field lines are perpendicular to the surface. They are curved, of course, but they start perpendicular to the surface and then curve, because the concept of field lines is in 3 dimensions. If this is the surface where they originate, they should be shown perpendicular to the surface. At the point where they originate, they start perpendicular. Okay? Here it is shown inclined to the surface. It is an error. Field line crossing is also an error. Field lines should not be shown inclined to the surface. So what is the correction? Correction number 1, remove the loop. Correction number 2 is no crossing of electric field lines. Third one, field line should be perpendicular to the surface and not inclined. So we have listed the errors and then also given the corrections. I hope the video was really useful to you. We will meet in the next video with another important topic, and thank you very much.